Now, we have to calculate electrostatic potential or electric potential at a point due to a point charge. So, see here, suppose there is a charge plus q here at this point which is greater than 0. Now, at a distance x, here a unit positive charge is placed here. So, obviously, it is experiencing electrostatic force to this side. So, we can write here F E is equal to Q E, that is equal to here Q is equal to, if you are taking 1 coulomb. So, obviously, F E is equal to here E. When this charge is brought from suppose A to point B here by a small displacement dx without any acceleration. So, you are bringing this unit positive charge from A to B without any acceleration, then the work done can be written here dW is equal to, here we can write F E dot dx, that can be written minus Q E dot dx, sorry Q E dot dx, and Q is equal to 1 coulomb. So, it can be written only here E dx cos theta, where theta is equal to 180 degree. So, we can write here minus E dx. So, work done dW is equal to, in bringing the charge from A to B, can be written here minus E into dx, and at the point A, E can be written Q upon 4 pi epsilon naught x square. Its direction is outward, so we can write here an x unit vector, that is radially outward. So, we can write here total work done in bringing the charge from infinity to the point, any point P. So, we can calculate that work done also by putting the limit and by using integration. So, by putting the value of E, we can get dW is equal to minus Q upon 4 pi epsilon naught x square dx. Now, if you are bringing the charge from infinity to any point P which is at a distance r from this, so we can write here W is equal to minus Q upon 4 pi epsilon naught, and here we can take infinity to distance r 1 upon x square dx. We can integrate it. When we integrate it, we will be getting Q is equal to 4 pi epsilon naught minus 1 upon x infinity to r, and this we can write minus Q upon 4 pi epsilon naught here is equal to minus 1 upon r plus 1 upon infinity. So, now this is the work done in bringing the charge from infinity to the point P at a distance r. 1 upon infinite is, that is 0 here. So, we can write W is equal to minus, that means plus Q upon 4 pi epsilon naught r. This can be given here the potential at point P, that is V. So, we can also write here V at a distance r is equal to Q upon 4 pi epsilon naught r. So, here we can write V is proportional to r, but we have done also in previous chapter E is inversely proportional to r square. So, it means electric field at a point due to a point charge is inversely proportional to square of the position vector, and where it is here the inversely proportional to r. So, see here the electrostatic potential at any point is defined as the amount of work done in bringing unit positive charge from infinity to that point in the electrostatic field and without any acceleration here. So, now as we have done here, the V is inversely proportional to r and due to point charge, and E is inversely proportional to r square. So, this is the variation of E and V with the position vector r here. So, now this is the graphical relation you can see here. So, in the exam you can get the question related to graph as well as numericals, where we have to calculate electrostatic potential or electrostatic field.